Hi, I'm Prof and welcome to Chemistry Matters. And today we're going to be having a look at solution stoichiometry. Today we're going to be having a look at a solution stoichiometry question, but this one's going to involve what happens when you mix two solutions and you end up getting a precipitate of something. So let's kick off. The question that we're going to be answering today concerns this material here, calcium phosphate. Now that is a pretty insoluble material in water, and we're going to be generating that today by mixing two solutions. We're going to take 50.0 mil of 0.2 mole per litre sodium phosphate, and we're going to be mixing that with 50 mils of 0.18 mole per litre calcium chloride. So the question then is, how much of this do we get? For the purposes of argument, we're going to say that this solid is insoluble in water. So let's think through what we're going to be doing. We're going to be taking a solution of trisodium phosphate, 50 mils of that, of a particular concentration. We've also got a solution of calcium chloride, 50 mils of that, of a particular concentration. We're going to mix them together. Bam, we're going to get a white precipitate out. We want to know the mass of that white precipitate that we get from this particular reaction. So what are we going to do? Well, very often in stoichiometry problems, the very best thing to do in the first instance is to write yourself a balanced chemical equation. Because remember, once you've got one of those, then you know your mole ratios, and that makes the problem easier to solve. So basically, the balanced chemical equation that we're going to be writing is for the reaction of trisodium phosphate with calcium chloride to give us calcium phosphate. So let's write our balanced chemical equation for this particular reaction, and we are going to start with trisodium phosphate, and that is going to react with calcium chloride, and one of the products of this is going to be, as we've already seen, calcium phosphate, so that's Ca3PO4 twice, and we're going to have another product as well, aren't we? What's going to be left over once we take the calcium out of here and we take the phosphate here? You can see that we're going to end up with sodium and chloride, so chances are the other product from this is going to be sodium chloride. So those are the identities, I guess, of the reactants and the products. Let's now go ahead and balance this particular equation, because if it ain't balanced, it's not worth anything. So how do we balance this? Well, let's see. On the right-hand side, we've got 3 calciums in this, so we know that we're going to need 3 calcium chlorides. Here we've got 2 phosphates, so we're going to need 2 phosphates over here. And then having done that, we need to check our sodiums and our chlorides. Here we've got 2 lots of 3 makes 6 sodiums. Here we've got 3 lots of 2 makes 6 chlorides, so that should then be a 6 in front of your sodium chloride. Just do a quick check, make sure we're all balanced up. 6 sodiums, 2 phosphates, 2 phosphates, 3 calciums, 6 chlorides. There we go, all done. So that's our balanced now chemical equation for this particular reaction. So having done that, we proceed as we would probably for any stoichiometric problem. We have a look at what data we've been given and we figure out what we can get from those data. So there are the data that we've been given, and from those data we can figure out which equation to use. We're given a volume, we're given a concentration. We know that the equation involving volume and concentration is this one here, C equals N over V. So therefore, knowing a concentration, knowing the volume, we can calculate the amount, and that for sodium phosphate is going to be 0.200 mole per litre multiplied by volume we need in litres, 0.0500 litres, and that then gives us 1.00 times 10 to the minus 2 mole. We do exactly the same for calcium chloride. We can calculate the number of moles of calcium chloride. N is equal to C times V, which is equal to 0.180 mole per litre, multiplied by, again, volume in litres, 0.0500 litres, and that's going to give us 9.00 times 10 to the minus 3 mole. Now, where do we go from here? Well, remember the question asked, what mass of calcium phosphate are we going to get from this particular reaction? And if we're going to be absolutely correct, we should really do this when we write our balanced chemical equation. We should say that this is aqueous, this is aqueous, this is a solid, and this is aqueous. That's just to stress that this is what happens when we mix these two things, okay? You get a solid precipitating out. Right, so this is like sort of, many stoichiometric problems in that we've now calculated amounts, and we want to make sure that our mole ratio is correct, because our mole ratio from the balanced chemical equation, 2 moles of sodium phosphate is going to react with 3 moles of calcium chloride. Is this then a 2 to 3 ratio? I think hopefully you can see that it's not. So therefore, if they're not in the correct mole ratio, this makes this a limiting reagent problem on top of everything else. So let's go through and see which of these guys is the limiting reagent. So remember, the number of moles of Na3PO4 over 2 should be equal to the number of moles of CaCl2 over 3 if we're talking about a perfect world here, okay? So because it's a limiting reagent problem, we're expecting that these guys aren't the same. Let's go and prove that. So the number of moles of trisodium phosphate is 1.00 times 10 to the minus 2. We're going to divide that by 2. That should be, in a perfect world, equal to the number of moles of calcium chloride, 9.00 times 10 to the minus 3, divided by 3. And again, you can pretty much see that this is not equal to this. This is going to give you 5.00 times 10 to the minus 3, and that's going to give you 3.00 times 10 to the minus 3. They're not equal. So therefore, we have a limiting reagent problem. The limiting reagent, remember, is now the smaller of these two numbers. So in this case, the limiting reagent is going to be calcium chloride. That gives you the smallest number on this particular treatment. Okay, so because this is the limiting reagent, we then base our calculations solely on this. We don't worry about the trisodium phosphate because that is not going to influence the amount of this that precipitates. Okay, so where to from here? Well, we now need the mole ratio between calcium chloride and calcium phosphate. So do the same sort of thing as here. So the number of moles, calcium chloride over 3 should be equal to, or is, in this case will be equal to, number of moles of calcium phosphate over 1. So anything divided by 1 is just itself, so let's get rid of that. And there's the equation we're going to be using. The number of moles of calcium phosphate is the number of moles of calcium chloride divided by 3. So therefore, the number of moles of calcium phosphate is equal to the number of moles of calcium chloride, which is 9 by 10 to the minus 3, divided by 3, and that gives you 3.00 times 10 to the minus 3 mole of calcium phosphate. That's the amount of calcium phosphate that we are going to be getting. Once we've got an amount, we are one step away from getting the mass. All we need to get the mass is then the molar mass of calcium phosphate. So let's go through and do that. So this is using our good old m is equal to little m upon n equation. So therefore the mass is equal to n times n. Here's your number of moles, 3.00 times 10 to the minus 3 mole, multiplied by the molar mass, and the molar mass of calcium phosphate is going to be, in this case, 3 times 40.08 plus 2 times 30.97 plus 8 times 16. 2 fours are 8 grams per mole there. And if we do that calculation, multiply those numbers all together, and then what you end up with is 0.931 grams. Okay, so there's your answer. If you go through and do this entire calculation, you start off with those two solutions, the one of sodium phosphate, the other of calcium chloride, mix them together. This then is the mass of calcium phosphate that you're going to get that precipitates out of this particular reaction. So there you go, that's what is going to happen if you mix those two solutions, the one solution of sodium phosphate, the other solution of calcium chloride, mix them together, you're going to get 0.931 grams of your calcium phosphate. Okay, so some important stoichiometric principles in there. How to figure out the mass of any particular material that can precipitate when you have got two solutions and you mix them together to give something that's insoluble. Again, in terms of the equations we've used, just those two stoichiometric equations, again, all the way through. Big M is little m upon n, and C equals n over V. As I keep on saying, to solve pretty much 99% of all stoichiometric problems, you need to use either one or both of those equations. Generally, the problem is figuring out how to use them. So hopefully that's given you a little bit of insight into actually how to use those equations and when to use those equations. So we'll see you next time.